Thank you, Chairman. I'm Satoshi Kubota from Kansai University, Japan. I'd like to talk about development of a construction information system by measuring, processing, and utilizing three-dimensional data toward creating a digital twin. Background. Construction sites are diverse and it can be difficult to use a one-size-fits-all method for acquiring three-dimensional data and point cloud data to understand the site conditions. Digital twins or cyber physical services are being promoted to collect data related to infrastructure and urban activities and visualize them in a 3D space. In the construction field, there have been few initiatives to collect and manage information on construction sites with the aim of creating digital twins that reproduce information from construction sites in cyberspace. It remains unclear which types of data can be acquired on construction sites. The method for transferring data between the planning, surveying, design, construction, inspection, maintenance, and renewal stages of infrastructure have been established. In Japan, construction initiatives are promoted by Japanese government. Construction is using ICT for all construction projects. Increased acquisition and use of 3D data and point cloud data in construction projects. For example, ICT earthwork is about 30% reduction in work time. However, there are several problems for promoting construction, such as high-cost equipment and the measuring instruments, and it is difficult to use such instrument for small or medium-sized construction sites. In this study, construction information system is proposed in which 3D data and point cloud data are distributed and utilized at small and medium-sized construction sites. A construction site digital twin based on 3D point cloud data is considered, and use cases for utilized construction information are discussed. We propose a construction site digital twin for processing the data collected at the construction site and visualize them, the construction site in a cyberspace. The status of construction work in the physical space. The data is acquiring, the data is collecting for using terrestrial laser scanner and camera photogrammetry. And the behavior of equipment and workers collecting using wearable device and camera. The results of these processes are reproduced in cyberspace. The analysis results in cyberspace are feedback to physical space. This slide shows the concept of construction information system. The construction site digital twin collects and accumulates data in accordance with data definitions. The system consists of measuring, processing, management, and utilization layers. In the measuring In the measurement of construction information, terrestrial laser scanner, UAVs, and camera photogrammetry are used to measure the shape and the changes of structure at a construction site. And wearable devices are used to measure the behavior of construction equipment and workers. In the processing, 3D data as a foundation of this system is constructed from the measurement data. In management, data is classified and defined by data characteristics based on the method of data collection and the frequency of data acquisition. In the utilization, the analysis of such data can be feedback to the site to review the construction work and inspect the structure. In the management of the construction information system, data modeling of information classified according to data characteristics and frequency of data acquisition was performed. And the class diagram using unified modeling language was created. We propose 3 use cases for using construction site information. There are progress management, quality management, and safety management. In progress management, the differences of the progress in daily work are compared. For quality management, the progress is recorded and the site condition and arbitrary data can be reproduced. In safety management, it is to realize the monitoring the worker's physical condition using wearable devices. In this study, we will introduce the use of data in volume management, visualization of progress, and grasping the state of construction. This is the slide is a summary of consideration for each stage of the cycle. The experiment was conducted for utilizing construction site information for creating digital twin. In the site, UAV, camera, and wearable devices, terrestrial laser scanner are used. Here is a list of the acquired data, such as point cloud data, video data, and operator's position. These data are used for digital twin of construction information system. In order to grasp the daily progress, it is necessary to calculate the daily work volume. We recorded UAV cameras data, and camera data is translated to 3D point cloud data using SFM and MBS technology. And these data are compared and visualized in heat map. This table shows the volume management of embankment work. For this study, the accuracy requirement is within 200 millimeters using the TLS point cloud data as the most accurate value. This is accuracy assessment by comparison of photogrammetry result with TLS point cloud data. For the more than about 22% of the photogrammetric point cloud data met the required accuracy of 200 millimeters. This indicates that the measurement method is appropriate and can be used for quality control. This is the system, construction information system we proposed. The system is this system is used for understanding the construction status by tracking back the time period. For example, embankment construction, for example, in embankment construction, there are pre-construction and progress topography data, camera images, and point cloud data are visualized. Camera images were displayed on the topographical data by setting the shooting position and direction. For using this system, there are merits for construction site, such as reproduction of the site conditions at that time by displaying data in different formats on the same base. Utilization as a record of detailed construction procedures from multiple viewpoints. And the system enables centralized management and 4D management for the future. Conclusions. We have developed a construction information system and verified the flow of measurement, processing, management, and utilization of information in order to promote the distribution and utilization of 3D data and point cloud data at small and medium-sized construction sites. And the system to realize the advanced construction management and the digital twin of the sites. Future works, we will examine the usefulness of construction information systems and propose a mechanism for sharing data among construction participants. That's all. Thank you.